In this section, we're going to remember how to simplify, basically evaluate algebraic expressions. And we're going to have these phrases and sentences that we have to pull information out of, and that's what the language objective is trying to tell you. Represent mathematical phrases in real-world quantities using algebraic expressions. So it's just practice. We're straight back in Algebra 1. We have some operations that we do typically, addition, subtraction, multiplication, division. And we also have exponents, and we also have variables in algebra. That's what makes algebra algebra. So we need to remember what the symbols are for all of these operations so that we can recognize them when we see them, and also what the keywords are so that when we're reading a story problem, we can pick out those keywords and know exactly what that problem is trying to tell us. Okay? So let's start with addition. Do we have a symbol for addition? A plus. Do we have any other symbols for addition that we know of? No, that's as far as we got, is a plus. All right, do we have any key words? Words that when you read them mean we're going to wind up adding stuff. Some. What else? The word and can mean, and I'm trying to write add. The word and, wow, can mean add. What else? Add. Now that I've said it 4 times. What else? Plus. What else? What's that? More than is a good one. Together or all together sometimes you might see. There's more. Definitely one more. I'm going to leave that one off because a quantity is an amount, not a sum necessarily. There is one more. Starts with a T. If I got a huge list of stuff and I add it all up, I find a what? Total. It's an easy one to forget, but it does mean add. All right, that's probably good enough for addition. Let's do subtraction. What's our symbol? A little dash. Do we have any other subtraction symbols? No. All right, give me some keywords for subtraction. Minus. What else? Okay, I got less than. I have subtract. I heard take away. There's more. Difference, good. Okay, we have sum, we have difference. We have add, we have subtract, we have plus, we have minus, we have more than, we have less than, we have together, we have take away, we have total. Okay, do we have anything else? Any other subtraction words or phrases? There is one more. It's like less than. It's just less. Less and less than mean 2 different things, but they both mean subtract. You use them differently when you see them. So we'll talk about that hopefully a little bit later on. The difference between less and less than. Multiplication. Do we have any symbols for multiplication that we know? We have parentheses. If you're on a computer, you might see the asterisk. We have the dot. The X is something that we've gotten away from completely, but I'll put it on there. We don't use that symbol anymore because it looks like a X variable. Anything else? There is one more. Yeah, 2 things right next to each other implies multiplication also. So, for example, if I have like x, y, I'm implying that I'm multiplying those 2 numbers together because they're right next to each other. So nothing also means multiplication. And keywords. Times is the big one. What else? I heard product. And then multiply. There's more. More than means add. Greater than also kind of means add. Of. 2/3 of a number. 2/3 times x. Of can mean multiply, so I gotta put that on there. Any other multiply words? We have times, product, multiply, of, nothing? All right, let's move on to division then. Do we have any symbols for division? The slash, like that. What else? Good, the fraction bar. A lot of people, okay, so the fraction bar with little dots above it like that. And then also the fraction bar. Nice, that kind of gave that one away. And then the long division symbol right there. So you have 4 division symbols. The slash, the elementary version, that division symbol that you learned at first. And then we also have the fraction bar. Remember that fractions are a division problem. They're just not done. And then we have the long division problem. We will be using this one in this class. We're going to be doing long division with algebra. It's actually kind of fun. It's pretty relaxing too. You guys will be so relaxed that day. It's amazing. Nice. I got one person listening right now. That's awesome. Oh, okay. One person gets me then. All right, keywords for division. There are a couple of very important ones. Divide is one of them. No, divide is a word, but it's not one of the important ones I was thinking of. I heard quotient is one of the important ones. You will see quotient in story problems all the time, and you have to know that it means divide. There's one more that I definitely want to say. It's a 3-letter word. No. No. Starts with P. Second letter is E. You got a 1 in 26 shot. It's not Pez. Per. The word per gives away division. If I say miles per hour, if I were to write that out, that would be miles divided by hours. The word per can mean divide. The word per can also give away something else, and we'll talk about that in a minute. Exponents. What is an exponent? Script. What kind of script? Superscript. Writing above the line, okay? So I have to put something on here so that we can see that we have writing above the line. That 3 there would be an exponent. It's the best I can do for a symbol. You could have any number for an exponent. You could have anything for an exponent. You could have a dog for exponents. Doesn't matter. It's just superscript. And it means repeated multiplication. Keywords. Yeah. Yes. You can have a variable in the exponent. You can have a variable for an exponent. If a picture of a dog is my symbol for my variable, then you're going to see a picture of a dog in the exponent. Okay? If that's where it belongs. Keywords for exponent. Yeah, we have 2 special exponents that we have actual names assigned for. It's squared and cubed. All right, square meaning the exponent would be 2, and cube meaning 3. And then we have a general word for other exponents, power. So x to the 2nd power would be read x squared. Okay? One more thing, variable. I've kind of already started talking about this. Do we have any symbols for variable? Anything you want. Typically we use letters. So x, y, In geometry, hopefully you saw the Greek letter theta. It looks like a O with a little line across it. You may have seen the Greek letter alpha. Looks like a fish, like an A, but like a fish. And there are others. Those are usually reserved for angles. But you could have anything you want, really. I could draw sunshine in here, and that could be my variable. It doesn't matter. The variable is a symbol only. It represents something that does what? That what? A number? Any number. It can change. That's why we use the word variable. Any changing number, okay? You can have a symbol that doesn't represent a variable. It represents a constant because that number does not change. Pi is a symbol. It's not a variable. It represents 3.1415926, blah, 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 okay? So, keywords for variable. There are a couple. The number. They might just come right out and say a variable or the volume V. That's kind of giving it away, but generally a number. And then the other key word that I want you guys to know is per again, or each, or a day. That would be kind of more specific, but basically what I'm saying is as you read these story problems, when you see things like per day, each hour, a student, things like that, that phrase usually gives away that there's a variable attached to the number you just read. So if it was 10 per day, then you would have 10x as you're reading through that story problem, or 10 whatever it is. That's the idea. All right, continuing the review to write algebraic expressions from word phrases. So we're trying to come up with like 10x plus 2 from an actual phrase. Here are the steps. As usual in my class, if there are steps to anything, I'll give you those steps right up front so that you have them, so that when you forget later on, you can go back to those steps and remember how to do this. So, step 1, start with a variable. Step 2, build out from that variable. So look at the phrase that you're given and try to decide what's being done to that variable first. Figure that out, write it down, and then decide what's being done to that thing next. And then what's being done to what you have now next, until you have everything taken care of. And then 3, finally, very important, especially in this class, you should always be checking to make sure that what you have written down works. So, for example, we have a number t more than 6. What is the key phrase here? Before that, where do we start? A number. We start with the variable, and then it happens that they're telling me what variable to use. A lot of times that's not going to happen, but here they said use t. And when I write t, I'm going to make sure that it doesn't look like a what? A plus sign. So I put a little hook on my t's. You guys might do that. You might use a script t. I'd try to write a script t, but it'd look awful, so I'm not going to. Script is like cursive, which you don't know. Italics. Okay? Here, fine. Here's a script t. See how awful it looks? That's my script t. All right? Just make it look like not a plus. So a number t, we have it written down. What are we doing to our number t? How do we know it's adding? Because it says more than, all right? That's one of those key words. So we see more than, we know it's going to be adding. And what are we adding? 6. Did we finish everything off? Yes, so we're done. Check it to make sure it works. We have t plus 6, a number t more than 6. Sounds right. Move on. Questions on that? Okay. Let's go to the bottom one, 2/3 of the volume V. Where do I start? No. The volume V. I did not say a number. This time I'm implying that the volume V is my variable, okay? So you have to be careful. You're not always going to see a number. You got to recognize that variable. Here it is right here. If I didn't have that written there, would you know what the variable was? Where would we start if we don't have that v sitting there? You're still going to start at the volume, because volume is the variable. We don't know what it is, so we have to tell it to be v. Okay? You start at the variable. Find the variable, start there. If you don't see a variable explicitly, look for a number. If you don't see a number explicitly, it's there somewhere. You got to find it. What are we doing to the volume v? 2/3 of, which means what? Multiply. So I'm going to write 2/3 right next to it. I could put it in parentheses. I don't have to. 2/3 times v is what I have written. 2/3 of the volume v is what they said. This looks good, so move on. The product of p and 6. Okay, the product of p and 6, I start at the variable, which is p. They told me it was p. They didn't say it was a variable. They didn't say it was a number. They just said p. So I wrote p. What am I doing to p? Multiplying by 6. How do I write that? 6p. A lot of times in Algebra 1, people would try to write p6. And technically that's not wrong, but the conventions of algebra say the number goes in front of the variable. 10 less than the product of 7 and f. Where do we start? With the variable, which is f. So I'm going to write down f. What am I doing to f? How do I know? Because it says the product of. I want to point this out to you. It says 7 and f right here. Doesn't that mean add? Right. So the word and can mean add. The problem is here, in this case, because of the fact that we wrote the product of, and then we have two things listed, the conventions of the English language force us to write and right here. So the only reason that and is there is because of English, not because of math. So you have to be able to recognize that, all right? That's why I wanted to point that out. So the product of 7 and f, how do I write that? 7f, perfect. Then it says 10 less than the product of 7 and f. We need to talk about this. Is this what we need to write? Or is this what we need to write? Or is there no difference at all? Is there a difference here? There is a difference. So it's important that we write this correctly. It says 10 less than the product of 7 and f. I see the 10 less than over here, so that must mean that this is the right answer. Right? No. So the example I'm going to give is this. If I tell you to do 25 push-ups, how many push-ups are you going to do? 25. If I tell you to do 10 less than 25 push-ups, how many push-ups are you going to do? 15. How did you get 15? You did 25 minus 10. Even though I said do 10 less than 25, you did 25 minus 10 for the math. Okay? Which one is that? It's this one. So we actually need to write 7f minus 10. Be very careful with subtraction. And less than, and the other word, less. If I said 10 less the product of 7 and f instead of 10 less than the product of 7 and f, then what I'm saying is I have 10, and now I'm taking the product of 7 and f away from 10. And that would be this case. So make sure you're being very careful. Always go back to that push-up thing that I just told you guys, and that'll clear up the less and less than problem. Less and less than is definitely the place where people make the most mistakes on this sort of thing. So be careful with that subtraction. Moving on, writing word phrases. So this is like 4 days into Algebra 1. We just covered a 4-day span of Algebra 1 here. Write word phrases from algebraic expressions. Look at the steps. Do you see any difference between what we just did and this? Not really. Start with the variable, write what's being done to the variable first, and then build out from there, and then check your answer. It's the same steps. It's just that now we're writing instead of making an expression. So let's take a look at this. If you read that, what does it say? It says, like if you were just reading it, you would say 5n, right? But we mean 5 times n. So let's write that. 5 times, instead of writing n, I'm going to write a number. You could have also said a number here. And then over here you could have said the product of a number and 5. There's lots of ways that you can write these phrases. There's only one way you can write an expression from words. But you can come up with several ways to write these. So just make sure that it works. We have to check it. Both of those work. So move on. 5z plus 16. Where should I start? Start with a variable. So what do I write? A number. All right. What am I doing to a number? Multiplying it by 5. So what should I write? So a number times 5. Sure. All right, now I don't have room, so I'm going to try to squeeze this last piece over here. So give me something that I can write over here that will tell me this expression. Okay, so I could write not plus 16 over here because that won't make sense. So I have to figure out a different word. 16 more than? All right, fine. 16 more than. And then we're going to read it to make sure that it works. 16 more than a number times 5. A number times 5 gives us 5z. 16 more than that gives us 5z plus 16, so it works. Make sense? How about this one? If you were to read it, it would be 3x to the 4th power. So now let's try to make that words. Where do we start? A number. All right, what are we doing to a number first? Good, it's to the 4th power. It's not times 3 first. Remember order of operations. We have to raise exponents before we multiply. So it's a number to the 4th power. Okay? I don't have room. Give me something that I could write out front. Perfect. The product of 3 and a number to the 4th power. And I want you to really soak in what this says. If you read it, I have the product of what? I know it's going to be two things, right? So I have 3, that's my first thing, and then I have the word and, which tells me I'm moving to my second thing, and then now I have a number to the 4th power. So I know that I'm going to have my variable to the 4th power. This is actually the best possible way to write this statement. The reason for that is there's no confusion at all. If I was to write the product of 3 and a number a different way, if I put times 3 here, I might get confused and think that I have a number to the 4th power, and the 4th power is being multiplied by 3. So you have to be careful how you word these. Make sure that what you're wording is clear so that people understand exactly what's going on. This one's perfect. All right, try that one. So I'll start with a variable. Which one? There's 2. A? Okay, so what are we going to write? A number. Now what? Okay, you could write times by 1/2, or you could write half times a number, or you could write, let's try to use a different word besides times. Half of a number, yeah. Half of a number, does that not say 1/2 A? Yeah, we're good. Okay, so we took care of that first piece. Now what? Plus. So we're going to write plus over here. Or you could say added to, or whatever. A number? A number. The same number? We have two different variables here. We have to make sure that we're not confusing people. We have to tell them that this could be a different number, all right? So instead of saying half of a number plus a number, I gotta say this is a different number. I want to use a different number or another number, something like that. It's a shortcut that I'm not a fan of, but yeah. So half of a number plus, what are we doing to another number? What are we doing to that another number? Multiplying by 6. So half of a number plus something, another number. 6 times, okay. All right, and there's one piece left. Over 7. Over is a division word, by the way. We didn't write that one down. You might go back and do that. Or you could say divided by 7. Sure. Is this a fraction? Is this something that I could read as a fraction? Yeah, what does that say? 6/7. So I could have also said half of a number plus 6/7 of another number. And that would have got it done as well. All right, so now on this, we're just trying to piece things together a little bit more. You start with $20 and you save $6 each week. Write an algebraic expression that tells you how much you save. Where do we start? Start with a variable. Do we have a variable here? Where is the variable? Each week. That each week thing right there gives away the variable. So just from that, what can we write? You want to call the variable W? Why? For weeks, sure. So we have W. What are we doing to W? Timesing it by 6. And what are we doing to 6W? Adding 20. We started with $20. That's ours. That's what we have right now. And then each week we're going to add to that. $6 per week. That's how you do that. Do I have to do anything else? Nope, we're done. So take a look at the second one, see if you can do that one. All right, we have $150 and then start spending $5 each week. What do we write? 5W, okay. Now what? Very important that you get this correct. I like that you see the minus. We know that it's minus because we are spending. That key word there is not one of the ones we talked about, but it's logical that it means we're going to subtract, right? Now, we start with $150, and then we start taking away money. Does that mean 150 minus the money we're taking away, or does it mean we have some money and we subtract 150? That's the question you got to ask yourself. We start with 150, and then we take money away. That's the answer. Okay, real quick, let's try to get through this. This is still just review, evaluating algebraic expressions. When you are asked to evaluate, evaluate actually means what? Usually, yes, you are going to simplify, but if you are asked to evaluate, you are usually going to substitute. So evaluate this expression for a is -4 and b equals 5. What do we do? So we write 7. Then we have this grouping symbol here. How do I write the next number? Anytime I substitute. In parentheses. Parentheses, -4. And then continue. Plus 4. Close the grouping symbol. Plus 3. How do I write that? In parentheses, 5. And then the -8. Use parentheses around things you substitute. That will prevent you from making sign mistakes later on. Like we have this negative sign sitting here. If you don't use parentheses, you may accidentally mess up that sign down the road. So what do we do first? Inside the grouping symbols first. So inside this grouping symbol right here is 0. Write down that step. So we have 7 times 0 plus 3 times 5 minus 8. This is the Algebra 1 way to do it. I know that some of you, as you go, can write some of this stuff down. and like do multiple steps at once, but let's go line by line. What's next? So what comes next in order of operations is multiplication and division at the same time from left to right. Okay? So from left to right. If this happened to be division right here and this was multiplication, I would do the division first. They happen at the same time from left to right. So as I move my way across, I have 7 times 0, which is 0. And then I have a plus sign. I'm going to leave that alone. I have 3 times 5, which is 15. So I'm going to write plus 15 and then the minus 8. 0 plus 15 is 15. This is addition and subtraction now from left to right. They happen at the same time, so I can do them at the same time. 0 plus 15 is 15. 15 minus 8 is, so the answer is 7. All right? I know that this is Algebra 2, and we can start taking little shortcuts here and there. I do want you to write down the steps, though. I want to see little anchor steps so that I know where you're going. Don't do too much at once in your head, especially on a problem like that. Evaluate that for x equals 6 and y equals negative 3. Talk me through this. What do we do? Okay, so I'm going to write 2. Okay. And I'm substituting in 6, so I'm going to write parentheses. And notice how I did this. I made a big parentheses for my grouping symbol that is there, and then I made little parentheses for my substitutions so that I can still see where those grouping symbols are. It really helps. And I don't want x, I want 6. I'm substituting in 6. Now what? So minus sign, parentheses, negative 3, parentheses, squared, close the grouping symbol, all divided by 3. Now notice what would happen if I didn't write those parentheses in there on that negative 3. What would I see? I would see negative, negative, and what do we do to negative, negative? It would turn it positive. And is that what this actually is saying here? No, it says square negative 3 first. Okay, so use parentheses. It will prevent sign mistakes like this. All right, the next thing we're going to do is just start evaluating this. We're inside the grouping symbol. We have exponents here and here, so we have 2 parentheses. 6 squared is 36, and then we have minus negative 3 squared is 9. Close the grouping symbol, 3. Now, did I do more than one thing at once there? Yeah, is that okay? Yeah, and notice I wrote down this step. Now I have a place to move to my next step. Inside the grouping symbol still, 36 or 36 minus 9 is 27. So now we have 2 times 27 divided by 3, because maybe I don't know what 2 times 27 is, and I better write that down before I forget. 2 times 27 is 54. So now I have 54 thirds. Does that reduce? Yes. Yes, to what? Well, it goes down into a whole number. Yes, to what? 18. So the answer here is 18. And that's the idea behind evaluating when they give you numbers to substitute in. All right, question at the bottom. Will the value of the above expression change if you remove the parentheses? If I remove these parentheses right here, will the value of the expression change? Yep. Why? Yep, because then we are changing the order of operations that occur. Before with the grouping symbol, we're in here. Now we're not, which means that this multiplication here has to happen before I can do this. You would do the exponents first, yeah, but then the multiplication would happen before these numbers here got combined. Whereas before, we combined these numbers and then we did the multiplication. 2 different results that way. So that's as far as we're going to get here. You can do 10 through 23 all at this point.